y is equal to a raised to the x. Did we sort of look at this earlier? Where they place restrictions here, the base of this exponential function has to be what? Greater than 0, but I cannot let it be 1. The x is open. You may replace x by any number you wish. If it takes that form, it's known as an exponential function. We did a little work with it. And please remind me, I think Mr. Park helped me out. Did we also finally, Monday, did we finally say that we could also accept a function that looks like that? Did we sort of derive or look at where that number e in math came from? And I think the approximation from Monday, that e is close to what? 2.718, was it?
Yes.
And he helped me off the table there. So that's another exponential function. Now, what shape do these graphs have? Well, it all depends. If I say, give me a quick sketch of e to the x, and we do calculus, so we're expected to do these graphs. Guys, what do you think the calculus instructor will accept for a quick sketch of what does e raised to the x look like? Just a quick sketch. Does it look something like maybe 2 raised to the x? I think we did 2 raised to the x Monday. Oh, yeah, this is right. What, 2.718 raised to the x, right? So should it basically take this shape, and I'll let that represent e raised to the x.
And the y-intercept of 1?
Y-intercept's always 1 on these exponential functions, unless they're being shifted. Okay, so the y-intercept is 1. The horizontal asymptote is the x-axis, or 0. Is that true, guys?
Yes.
So that's what an exponential function looks like. Here's my intro to class tonight, though. If on your exam, now the next exam 4 for us, is not next week, it's the week after. And that's another one that I'm worried about. And I'll have a nice review for you. Because of all these functions coming up, inverses, exponentials, logarithmic functions coming up tonight, maybe something like this, sketch, as I'm thinking about that exam coming up, sketch this. It's called f of x is equal to, yes, 2 raised to this, subtract 4. Now, can anyone tell me if you were approached and had to do that, and then do a little calculus on it later, and we'll see the sketch first, give me an idea, how would you sketch that? And maybe I should use the word, use transformations, which may help you. So guys, if I start using transformations, what should I place on my grid first, that we always do, if we were to do it through transformations? The parent graph. And the parent graph here, bring it up here, will be merely this. Let's say 2 raised to the x. And that should take the same shape as that e raised to the x we saw earlier. So something like this. And I'll label that this represents 2 raised to the x. Now, remind me, let's see if I have enough colors here. What might you suggest now? I got the parent graph. I'm trying to graph this. Now what?
After add a negative 1 from the 2 makes it.
Oh, look at that. First, also it says professor. The way you have this written, that x should come first. So rearrange it up there. You guys agree? Then he said, hold on, you should, based on what we've done in this class, to do what else? Factor out that -1 or negative sign there in that exponent and make it look like that, and then subtract 4. Everyone agree? Now it's in the proper form that we want to start looking at these transformations. Guys, the transformations, let's see if that red will work for me. This might tell me what is happening as a transformation.
Reflection about the y.
A reflection through the y-axis. If it were the x-axis, the negative sign would be out front. So this is a reflection through the y-axis. Got that done. I'll do that in red here, guys. In fact, I should do it right now since I'm talking about it. So I want to reflect this to the y-axis. Please tell me just for a rough sketch, might it look something like that? And call this y is equal to 2 raised to a negative x. Yes or no? Now, if I go back to my blue here, try the green to do the next part here. The x subtract 2 might tell me to do what from there? Horizontally shift that over 2 to the what? Right. Now, one nice little reference point is this point right here, 0, 1? So if I take it, what, 2 to the right, now I'm at what, out 2, up 1? That'd be a nice little reference to work with. And let's see if this green will work for me. So let's say it's right here. Now, do I have enough right there to get a quick sketch of what it says there to horizontally shift it 2 to the right? At least I shifted this point here 2 to the right. What might you suggest I do? Can I get additional points? Or can I just base it on that one point and do what I gotta do? Tell me again. Okay, now can you find that I'm doing this to, right here? Yeah. Maybe what? Change yourself, maybe find the y-intercept if I could. That would maybe help me see what that green's going to look like. And by the way, will it still approach the horizontal asymptote down here, whatever it is? So is it going to do, it's going to sweep down something like that, for sure. And she says, Professor, you could even make it look better if you found the y-intercept on that. But I see now, for sure, just a rough sketch. Shane, I definitely heard what you said. It looks like that. By the way, it does that green graph even on my rough sketch. Does it look like it's to the right of the red one? Is that true? And did we say it should be horizontally shifted to the right? So at least it's to the right of it. So guys, this represents y is equal to, what was it, 2 raised to this, x minus 2 for the green. Everything good now? What's my last step? Horizontal, vertically. Vertically shift it down how many spaces? 4. If I try to show that and finish it up, as I shift down vertically 4, guys, negative 4 there, I gotta be careful. Is that horizontal asymptote, which is the x-axis, also being shifted down? So I gotta be very careful. I don't mind, let me do this. I'm just gonna put a broken line, let's go ahead and do it like this. Let's see what happens. And I'm trying to take that, what was it, the green graph? Here's the green graph. And I'm trying to do what? Vertically shift it down 4? So guys, here's a nice little reference point. Did we say the reference point earlier was what? Out 2, up 1? Is that true? So out 2, up 1, even that individual point shifted down 4 is now going to be where? Out 2, down 3, I think. Is that true? Down 3?
Yeah.
Okay. So that means, let's do this in blue if we can. At least for a reference, this point right here, guys, shift it down 4. I'm here, it's going to fall right there. Out 2, down 3. Might that be enough? Or what do you think I usually ask when I ask you guys to do a transformation? When you finally get to the last, which is the graph, what do I usually ask you to find? I usually ask you to find the x and y intercepts for sure at the end, don't I? On transformations. So the x-intercept here, go ahead and do it. On this last graph. And guys, I'm trying to find the x-intercept on the entire mess here. Set this equal to 0. And that's this. Now, can someone help me out on how to solve this? Now you're going to solve that for x. I've got to find x. If I set this up correctly, I set the function equal to 0. What would you suggest? Move the 4 over. Being clever. And then even being more clever, you might want to rewrite that 4 as 2 squared at the same base. on each side. I think I have the same base, therefore common sense tells me these two must be the same. Must be equal. So if I set those equal, 2 is equal to what? 2 subtract x. Guys, if I solve for x, is it 0? My x-intercept is 0. So it's here. In other words, the y-intercept also 0 then? If the x-intercept is 0, should the y-intercept also be 0? Absolutely. Do I have enough now to take that same shape of the green, connect those two with the blue, follow my horizontal asymptote, let it look something like, I'll make mine do this. Might it look something like this as it comes down, sweeps down, and follows that horizontal. Might it look something like that, or a rough sketch. We got a rough sketch here. May it look something like that, guys? Yes or no?
Yes.
And that in the blue is the final graph. That is what they asked you to graph initially. 2 raised to the 2 subtract x, subtract 4. And we did 3 transformations. Domain on this graph, before I leave it, domain easily seen for the blue graph. It's negative infinity through positive infinity. Now be careful. Anyone tell me the up and down the range on this blue graph? Yeah, it drops down towards -4, we'll never get there. It rises forever, -4 through infinity. And that's what we're talking about. Now I brought that in for a reason. This one's done. I've got the graph finished up. We did 3 transformations. Now part B, here we go. I will give you, all these markers will work for me, a function, a simple function. Let's call it f of x is equal to 2 raised to the x. An exponential. And to lead into where I need to go tonight, I need now to ask you to find this. Find the inverse. I know what 2 raised to the x looks like. I used it over there, I think. Didn't I? I used a 2 raised to the x graph over there in my last graph. So I know what the graph looks like. But now I want to know what is the inverse first of this function. Guys, to find the inverse, the first question I should ask myself, is it what? Is it 1 to 1? If it's not 1 to 1, you leave it. It has no inverse. Guys, this function is, we have a graph over there, we pass the horizontal line test. It definitely is this. It's 1 to 1, so it will work. It has an inverse. 2 steps to find an inverse. Interchange in the original function, the x and the y. I give you partial credit, just show me that. Now, number 2, I think this takes me right to where maybe we were sort of ending class Monday. Next step, second step, last step, to find an inverse is now to take number 1 and solve, get the y by itself. And this is where I remember Monday I heard different responses. How are you going to get that y by itself? I think somebody said divide by 2. Can't do it. Divide by y. Can't do it. This is what takes me into my lesson. Does anyone think they know what the inverse is? How to get the y by itself? I wish you could divide by 2. That'd be so much easier. Alex, go for it.
Log subscript 2.
Come again.
Log is subscript 2.
Oh, you're telling me, hold on, Professor. The only way you solve for y, this was a little tougher. He says y is equal to log base 2 x. Alex, is that what you're thinking?
Yeah.
So let me make this a stronger statement. He's saying, Professor, that's the inverse. The reason I brought this in at this moment, some of my students may say, yeah, I may have heard the word logarithm, or the abbreviated log, but Professor, Alex gave me this. I really don't know what a log is, Professor. I've heard the word, but it's been some time since I have done something with log. So I got to slow down and see where he came up with this. A little side lesson here. Let's take the word logarithm. Abbreviated log. I want you guys, from me, in this class, when you see that word logarithm, or the abbreviated log, think of this. Associate it with this. Exponent, which is an exponential function back here, shortly. So the professor already talked about. If I saw this, and let me put a few of these on the board here. I think I brought in a few in my notes here. Let's check and see if I did. And maybe we can do it. Yeah, I did. Okay, here goes. I start out with this. 3 raised to the 0 is equal to 1. Guys, we'll play some expressions from middle school that has exponents. I want you to focus on the exponent. That's a true statement. Another one I brought in is this one. 2 raised to a negative 4. Everyone should know that's 1/16. Number 3, 8 raised to the 2/3. Everyone should know that's 4. Do we all know that's 4? 8 raised to the 2/3. I placed 4 there. Do we realize, is it 4? Can anyone give me a translation if that exponent is a fractional exponent? How did I get 4? What does that 2/3 translate into me doing to get to 4? Translate for me. You've seen it before somewhere in your math course, you've forgotten. The bottom number tells you what root to take. So I'm taking the cube root of 8. And the cube root of 8 is what? 2. And then the top number, numerator of that fractional exponent, tells you what to do as a power. Then take that number and square it in this case. So cube root of 8 is 2, then square it from the top, you get 4. Number 4, I'll throw in another one here probably with a fractional exponent. I have this one. Just some exponents to look at. Move into this. 16 raised to a negative 3/4. Now let's slow down this one and do a little work with it with your help here. Beautiful. Guys, help me out. Does anyone know what the negative sign with that exponent indicates? And then, of course, I threw in another fractional exponent, and all that all together. Someone help me. What's that going to do?
1/8.
Well, it's going to be 1/16 first. Yes or no?
Yeah.
Does that negative sign ask you to take the reciprocal? So if you see a negative sign with an exponent, it says take the reciprocal of that base, which is 1/16. Then you're left with the fractional exponent 3/4. I translate this one for you. I said this makes cube root of 8 squared. This one translates, says take the 4th root of 1/16 and then cube it. That's what it means. And here the guy's 4th root of 1/16. Is that a perfect 4th root, by the way? 4th root of 1/16 is what, 1/2? And you got 1/2 cubed. And I hope we realize that's what, 1/8. Wow. Now before I show you the connection here, I've got enough examples of exponents here. Let me block off those exponents. They'll play a part in my next lesson. Before I show you that relationship, on the side here, some students have come to class in the past, and they're saying, Professor, if I saw this, what is the answer for that? Tell me again, I hear it.
-4.
It's supposed to be -4. Not 4. Now, it does not mean this. If I had written it like this, that is, as I heard some students tell me earlier, that's 4. This says you're squaring only the base of 2. The negative sign's still there. If you square that, of course, you get 4, and therefore the answer is -4. That's why I was careful in my examples over here. I don't think I have any negative signs to worry about here on this. But be very careful on this, guys. Sometimes students will think a -2 squared and nothing else about it, it's going to be a 4. It is a 4 if it's enclosed in parentheses. Okay, so that negative sign's not in there, that negative sign inside the parentheses, the negative sign's out front. Now, what am I doing here? I want us to go through, here we go, and focus on those exponents for a reason, and try to get into this lesson. Now, please tell me, what's my exponent in my first example? 0. Is it 0? So I'm saying with this word logarithm, which I'm trying to translate what it means here, I'm saying logarithm, please associate with the word logarithm exponent. Well, the exponent in this case is 0. So undoubtedly the log is 0. Professor, what does that mean? I'm saying the exponent is 0, and I'm going to associate exponent with logarithm. So we use the abbreviated form, we'll say the log, look at this, is equal to, notice I'm going to leave a little space, is 0. The exponent is 0. Now, why did I leave a little space there? I got to be more specific as to when is that happening here. It's happening when I'm using what? Base 3, written as a little subscript of 1. So 3 raised to the 0 is equal to 1. Could be expressed like this. These two are saying the same thing, just written differently. If that's true, this one, the exponent was -4. So if the log is being associated with the word exponent, the exponent's -4. Now I got to fill in. When is that happening? When my base is 2, and I got a 1 over 16. That's what that means. Next one, 8 raised to the 2/3. We did it. It's 4. So I'm going to say this is log. And the exponent out here is 2/3. And when is this happening? When the base is 8 of 4. I throw in one more here, my last one here in the green. Log. By the way, guys, log in this case was what? -3/4. Right here. When's that happening in this particular case? When my base was 16 of what here? 1/16, was it? Or was it? No, it wasn't. I'm looking at it wrong here. Base 16 of what?
1/8.
Yeah, 1/8. Now, is everything correct now? Who would have thought the word logarithm, log, just means exponent? Now, right quickly before I go any further and then make an association here with this, because they are connected. I'm calling some students here. Jeez. Who can I call? Shane. Shane, help me out. Put Shane here. Shane, suppose I walk up to you and I ask you to say, what's the log of, here goes, what's the log of 100 base 10?
Log of
100 base 10. Just give me, I don't put you on the spot, just think about it. Log of 100 base 10.
2.
Thank you. I'm asking for the exponent. 10 raised to an exponent of 2, 10 squared is 100. So the log of 100 base 10 is 2.
Is it always phrased that way?
Always.
You don't say subscript?
Yeah. Look at this. I just ask you this. What's the log base 10 of 100? And you said, Professor, it's 2. That's what I was asking her. Merely 10 squared equals 100. And we write like that. And by the way, since I use a base 10, that's called a common logarithm with a base 10. Ignacio, I'm going to place this one on the board. I walk up to Ignacio, we're walking on campus, and I see him, and I say, come here, Ignacio. How you doing today? He said, oh, I'm fine, Professor, I'm good. Well, what's the log of 4, base 32, Ignacio? And he may give me a different response. What's the log? Got to put you on the spot. The log of 4, that's a tough one. The log of 4 base 32. In other words, I'm looking for an x bar. Does anyone think they know what it is? If not, you got to call on you, but anyway, Alex, hang on just a second. You'll say, Professor, in my mind, I know how to translate it. I don't know the answer right now. Ignacio may say, Professor, I know what you're asking. You're asking this. 32, base 32, is being raised to something to give me a 4. Well, you guys, is that the translation?
Yeah.
That's what it means. I'm looking for x. Raise 32 to what to get 4. Well, that's even tough. I would suggest, what, rewrite 32 as 2 raised to the what? 5th, thank you. And that's still being raised to the x on the outside. Let me be specific here. And the 4, thank goodness, can also be expressed as what? 2 squared. Is that true? Now I have both those in terms of a common base. Therefore, common sense tells me this must be equal to this. And if I set 5x is equal to 2, Ignacio's going to say, Professor, your answer is 2/5. This is 2/5. Log of 4, base 32, got to do a little thinking, is 2/5. That's exactly what a log means. One more here. Let's see who I like here. Vincent, you've been such a big help to me today. Guys, listen carefully. Give me the answer to this. What's a log base pi of 1? Let me jot down the board so you will realize what I'm saying. Log base pi 1. I'm not putting anyone on the spot there, just trying to get some feedback from you. Is it, I'm hearing someone say, is it 0? There's a Professor, why? Because if you take the base pi and raise it to 0, you get 1. So that's what these logs are all about. Alex, the reason I did that little side lesson, because you said over here I had a log involved. And I do a little refresher here to remind students first, what is a log? And it looks like it's this business here. You're looking for an exponent. Now, if that's said, though, on the side here, let me give you the, let's see if I have it. The definition your textbook uses, or they do, for a log. Here it goes. Y is equal to, it's like a definition. Y is equal to log base A of x means, and your textbook describes it like this, it means A raised to the Y is equal to x. And they give you a few restrictions. The base, you guys might tell me now what the base might have for a restriction. What was it over there? It's got to be greater than 0 and do not let it be 1. In other words, right here, that's my restriction on the A. A must be greater than 0. Do not let it be 1. Now, I haven't graphed or shown you the sketch of a log yet. A log function. This is a function. Some students may know, Professor, there's also a restriction on the x. In my few examples, let me see if I have here. Here's my x. Here's my x. There's my x. Where was it down here? Maybe that was the last one. Here's an x. Guys, those few I did there with that. Oh, here's another one. That plays the part of the x here. Is that true?
Yeah.
Just so happens all those numbers are, you would tell me what would all those circled numbers be? They're greater than 0. They're positive. Therefore, this restriction is x has got to be greater than 0. And by the way, we know what x is. That's the domain. And the domain of a log function must be greater than 0. Now, y, let me go back. I know we'll connect all this. if you're asked to find this, log base 2 negative 4, where the restriction says make that x always positive. I'll throw a negative in. Is there an answer to that? 2 raised to what will give you negative 4? Nothing. Right? Will 2 raised to something give you a negative 4? Absolutely not. So that's why they put that restriction. Also, if I ask you this, I'll say log base 3 of 0. Translate says 3 raised to something, it's going to give you 0. Good luck. You won't be able to raise 3 to anything to get 0. Okay, I know if you raise 3 to 0, you get a 1. But here, no. So that's why also they're saying, please don't even consider 0. Make everything greater than 0. Guys, how's this look? Now, let me go back. Here we go. With your help, I'm going back to this. This is an exponential function. And then all of a sudden, we now have a definition for a logarithmic function. This is a definition for a logarithm. I'd like to do something with those two functions and see if I can get the response from you. These are the examples I used. And this will help you greatly before you get the handout. Here goes. You guys just try to find. Number 1. I think of a good way to do this. Why not? Let me give a name to these. I'm going to call this function g of x. We'll go back to where I started, the exponential function. I'm going to call it f of x. And to make everything connect for us, I like to find this. I like to take those two functions and do a composite. And the way that I have this composite written, guys, it means f of what? G of x. We've done composites before. G of x is the one I identified back down here. I guess that's my log function. So that's log base a of x. Then what does that mean to do? Now jump over to what? My exponential function, right? And make a replacement there. By the way, guys, f of log base a of x would be, here's my f function, would be a raised to, if you guys agree, this. True? That's the composite of that function I started out with today, and then this function. Does anyone know what's going to happen here when I take a composite, which I did, and I'm down to here? Can I say anything else about this? And please tell me what you think that response might be. What is a raised to log base a x equivalent to? Shane.
X.
Oh, wow. Shane, tell the class, why did you say x first? You're telling me all that mess is just x.
Because they're inverse functions.
They are inverse functions. This function, a raised to the x, this function, logarithmic function, are inverses. Now, I'm going to make sure Shane's correct there. If they are inverses, that composite should be what? X. Now, on the side here, let's do this. Given, this is a nice lesson that I should get that chapter 4 closing out here. I'm going to take my f of x function, yes, over there, which is a raised to the x. I'd like to find its inverse. By the way, is that a raised to the x? I did 2 raised to the x. Is that a one-to-one function? If it is, it has an inverse. I think your textbook tells you they are one-to-one. So I'm supposed to find the inverse. I'm going to try to find it. 2 steps. Step 1, interchange. Step 2, always, only 2 steps, solve for y. Now, can anyone tell me x is equal to a raised to the y? I've got to get the y by itself. In other words, I've got to solve for y. Does anyone think they know what it is equal to? Alex?
Log base ax.
That's it. That's the only thing I can say. And in fact, I think I have it right here. That's it. So Shane, you are correct here. So if I give you an exponential of some sort, its inverse is a log. If I give you the log first and ask you to find the inverse of it, it'll turn out to be an exponential. So they are related that way. They are inverses. And we had a property that says, Professor, if you take a composite of a function with its inverse, you're supposed to get x. Is that true? We've talked about that. And she says, that's why she says, Professor, this looks strange, as you know what? But the answer is x. It fits this little description we're doing here. You guys agree? That makes sense? Okay, so that is one property here that comes out. Now, with that property, I don't know, on the side here, I'm all over the board here, I'm getting excited about this. If you saw this, 2 raised to log base 2 of, let's say, 14, and you were asked to give me the value for that. Looks strange as you know what? Answer merely is 14. Look at that, based on that property. If I saw 3 raised to log base 3 of pi, automatically, pi, based on that property. If I saw this, let's say, let's trick pi raised to log base 4 of 6. Now what might you say? Is it obvious in this case? The answer is obvious again? Can I say merely the answer is, I think 6 here? Is the answer 6? No, I messed you up here. You can't do this one unless you use the calculator. What's wrong? Do these match up? Do they match up here? I got a pi and what? A 4, don't I? I can't do it unless I turn to a calculator. So there's no answer. Or there is an answer, but you got to use a calculator. Now if I go back and do this, everyone in class would say, hold on, Professor. Now it matches exactly what you want. Now is the answer now 6? All based on that property. Okay, guys, so inverse of an exponential, a logarithmic function, they are inverses of one another. By the way, let me do that, which I've done. And before I get that handout to you, let's form the composite. Where was it? I formed my composite like this. Let me turn it around. On these 2 functions. Here's my g function. So I'm looking for g of f of x. F of x was, I think, was f of x the original function back here? Which was what? Was it 2 raised to the x? Or a raised to the x? A raised to the x. And I want g of that, which says now go to this function, identified as g, and put that in. You have log base a raised to the x. And if there are inverses, what should that be equal to? X. So if you form a composite of a function with its inverse, you always get x. That's why we sort of check these also. Did we not check some of these in class? Actually found the inverse and we went through a check to see if we got x. Do the same thing here. If I solve this on a test, they ask you to find this. Log base 2 raised to the 25th. Answer is 25. That's the property. Comes out. If I ask you this, log base 4, let's say 16 raised to the second, can I say anything there? Can I say anything real quickly there or not? I don't think I can I? Or can I do something to it? Can I rewrite 16
Yeah.
as what, 4 squared?
Yeah.
And I did use 4, didn't I? So could I rewrite this as log base 4 and 16 is what, 4 squared? And that's being squared. Is that true? Which makes it what, 4 raised to the 4th? Now, is everything now good with this property? Is the answer really what? 4. Mathematics. But you gotta have something to use, and we're using properties here, to make all this happen. So guys, we do this. Let's see if I got enough space over there. That's the graph of, let me look at it. Oh, that was a separate graph here. This was the graph of what, e to the x? I think, wasn't it?
Yeah.
Okay. By the way, is e to the x also an exponential function? Does it fit this form? Where e is roughly 2.718. We're going to identify e to the x is also an exponential function. Therefore, it should have an inverse. So if I ask you to find the inverse, and I'm all over the board here tonight, I'll organize this up here shortly. Let's call it f of x is equal to e raised to the x. Find its inverse. Now, I will tell you ahead of time it's 1-to-1. The function is, we'll pass the horizontal line test. Since it's 1-to-1, I want the inverse, interchange. You have this. Now, can someone tell me, please, what can you say y is equal to based on what we're talking about here? I'll tell you, algebraically, you can't get y by itself. But can you tell me, based on that log function down there, how would you express y is equal to what using that log function?
Y equals log E of x.
Base e, thank you. Okay, is that true, guys? And by the way, if you translate this, this means e raised to the y is equal to what, x? Just like I was translating those down there. With me? Now, if it is base e, your textbook and all the calc textbooks and all the books from now on, they identify this with a different abbreviation, not log. They call it ln x. So if you see that notation ln, another way to abbreviate, they want to abbreviate logarithm with an ln rather than log. If you see this, it's understood to be a base e there. It's not written for you, but if you see ln, it's understood to be a base e to work with. Wow. Whoa. Are we okay? Mr. Park, would you get those handouts passed out? Yeah. I think I'm ready.